Hi guys, good evening. All right. Let me see. You guys can see my screen, right?
Yes, sir, we can see.
Perfect. All right. So today's presentation is on AWS plus with serverless as well. So I'll be doing a very small introduction to AWS with a tool called AWS EC2. And then I'll be going through serverless technologies and how to use that in a more superficial way. So just to start, a quick question to everyone. How many have used AWS as of now? Maybe you can put it in chat. Right, seems no one. Uh, have anyone used Python before? All right, cool. Uh, and have anyone used AWS Lambda or any other serverless technologies like with Azure or Google Cloud or anything like that? All right. So I presume that is a new arena for you guys, right? So so today's agenda would be we'll have a quick introduction to AWS Cloud, and I'll do a small demo on EC2 with AWS Management Console. And then we'll step into serverless with AWS Lambda, and we'll go through the pros and cons and when not to use Lambda or any other serverless technologies for that matter. And then we'll do a quick intro to Python Flask. You might have used that, so if you have used that, it's quite easy to understand. But what I'll be brushing up with would be a very minor area of Flask, and it should be demo. So the next one is a demo to with the AWS Lambda, but in the management console. And if time permits, we'll be going through something called serverless framework, which is an open source tool which we can use to orchestrate or rather automate deployments to these serverless tools such as Lambda. So finally, we can open for questions. So to start off with, now you know AWS is a cloud service provider, right? It's a cloud service provider. So what is a cloud? In layman terms, we have on-premises infrastructure for your servers, or else we can go with the cloud. Cloud essentially is actually a set of machines, physical machines that is located in a separate location, maybe geographically distributed, so that people can use it when they want, so that they can scale their applications according to their needs. Because let's say you have a on-premise server, right? Then let's say you have 100 users now. So you have a very small machine for your server, but overnight, because of a tweet, your application now has around, let's say, 1 million users. So how to scale it? So in order to scale your open on-premise infrastructure, you have to add more hardware. But in cloud, it's almost instantaneous. So you can do it then and there. You can scale dynamically so that you can serve your customers. So cloud is essentially someone else's computer in layman terms. But we use it when and only when we want. So that brings us to the AWS cloud. So there are many different providers which gives cloud solutions. So one being AWS, another one is called Azure, which is from Microsoft, and there's another one called Google Cloud, which is from Google, of course. And but with all of these three major players, AWS has around 40% of the penetration in cloud. So AWS is the biggest and most used cloud service provider in the world as of now. So it is on demand, right? You can use these servers, you can use these compute resources only when you need, as opposed to a on-premise one where you have to do pay for the electricity and bandwidth and everything, even when the time you are not using that. And it's extremely, or rather I would say even infinitely scalable. So you can add more and more resources in cloud instantaneously rather than using an on-premise solution. And they innovate. So what means by innovation is, if you are to manage your own infrastructure, your own resources, you have to do a lot of things. For an example, you have to see what's the load which comes to your servers, and how to propagate this load into different machines, if you can, so that the load will not be in the single server. So all of these you have to do yourself. But if you are using AWS cloud, there are tools which they innovate day by day, so that it will give a better solution day by day, right? And one of the most important things is the security. Now, people say sometimes having your servers on premise is secure. In some cases, yes. For an example, if you are a government, if you are a defense related provider, maybe having your servers in on premise means something. But then again, it wouldn't work in a normal server client situation, right? But if you are a normal enterprise solution provider, cloud actually gives better security than on-premise. Cloud actually gives better security than on-premise. Why? Because they have their tools, they have their security measures which are tested, battle tested. Because rather than writing your own firewalls, rather than setting up your own firewalls and own tools for security, they have their own tested by millions, like tools that we can use. So it's very secure. And one of the most important things when it comes to AWS cloud, or even any cloud for that matter, is their global reach. For an example, let's say you have customers in Singapore, in US, in Australia, in UK. Let's say your servers are in India. The amount of latency that would be on your customers maybe in US or UK or Australia will be much higher than the Singapore ones. So in order to eliminate this, AWS has the global reach. For an example, you can have your application replicated. You can have your application replicated in many different regions. So that brings me to one of the most important aspects of AWS cloud. So there are three main things when it comes to the global reach, the global infrastructure of AWS. First thing is called regions. Second one is called availability zones, and third one is called edge locations. So these are very important. Typically, a region is a physical area, a region in the map, so to speak. For example, we have a region called Singapore, and we have a region called California. We have a region called Mumbai. Then we have a region called Sydney. We have a region called London. So these are actual physical regions. So inside a physical region, you might have different availability zones. With the name, it suggests these zones are actually there to replicate your applications or your data. For an example, let's say in AWS, there's a offering or a tool called S3. It's a file storage offering which is available in AWS, right? Let's say you have very important set of data in that particular file storage. If it's only saved in one of the locations, let's say for some because of some disaster, those servers have corrupted or burned or destroyed. So So all of your data will also be destroyed, right? Because these are, at the end of the day, are saved in physical drives. So why we have availability zones is that your application or even your data, that your particular file which is very important to you, will be replicated in many different zones, many different data centers inside a region. For an example, let's say we have a London region, we might have 3 different availability zones in 3 different physical locations. So in these physical locations, all of your data will be replicated, right? So the last one is called edge locations. Edge locations are there to address that first issue that I have mentioned, the bandwidth or the latency issue. For an example, let's say you have a website that you hosted, a streaming website, right? That streaming website is hosted in Mumbai, but if someone from US or UK is trying to access it, that will take a lot of time given the bandwidth, right, and the latency. So what you can do is, in AWS, there's something called edge locations where you can have your data cached. You can have your data cached in these edge locations so that people who will be visiting from, let's say in UK will not actually be redirected to Mumbai, but rather an edge location in London, right? So that's the basic architecture which Netflix uses, because Netflix infrastructure is completely driven or run in AWS. So what they do is they have their film files or TV series files or whatnot in the file storage, and this is actually cached in different edge locations, so that you don't feel the latency when you go and watch these movies or whatnot, right? So to give you to illustrate this, for next, a region will have multiple availability zones, and in one availability zone will have your resources. So for an example, RDS is the database server offering which AWS gives for SQL databases or relational databases. So you can have your database, you can have your database replicated in 3 different availability zones for high availability or fault tolerance. It basically means if, for an example, if for some reason one database fails, it doesn't matter because there are 2 other similar databases running, so that your application will be running smoothly. So there are many different offerings, services which AWS has given. These are some, and some of the ones which are used mostly, right? So you have deployment management. For an example, let's say you have GitHub, right? Or Bitbucket. Similarly, AWS will also give you different tools for to have your CI/CD pipeline or continuous deployment and continuous integration pipelines. Similarly, you will have application services. For an example, let's say you have a IoT device, right? They usually send messages, right? So in order to listen to these messages, AWS might give you one solution, which is called maybe SQS, which is the simple queue service, something like that. Or else maybe, let's say, you want to do a login. You want to do a login screen for your application. Let's say you want to have your all the social media login like Facebook, Google, and whatnot to be used for your users to log into your application. So for that, you can use something called Amazon Cognito. So these are different tools which are available for different categories. For example, the compute, or rather your servers. They would have one called EC2, which is like a virtual machine. And the second option is something called AWS Lambda, which we'll be discussing in the latter part of this session. right? So these are set of tools that AWS has provided. Yeah. And in order for you to just a second. Yeah, in order for you to communicate with AWS, let's say you now have created an AWS account. Let's say you have created an AWS account. There are three ways actually you can communicate or you can use AWS solutions or services. One is called AWS console. This is the GUI console, the web application console. You will have 80 to 90% of the tools can be used with console without any issue. Basically, you don't have to code at all in some cases. You can just simply click some stuff and get your server working. The second option is called AWS CLI, the command line interface. So that what it does is it will give programmers programmatical access to your AWS solutions. For an example, let's say you want to create a continuous deployment or auto deployment server, right? So for that, you cannot use the AWS console because it requires a person actually go and do stuff. But with AWS CLI, you can write a small script which utilizes the CLI commands and do the deployments to AWS services. Third thing, let's say you have an application and inside the application you want to access AWS services. For an example, let's say you are developing for Netflix, right? So for Netflix, you want to get whatever the movie files you have stored in your file storage, which is S3, to retrieve that in your application and show that in a player to the user. So for that, both first and second option will not work. Then for that you have to use the software development kits or other SDKs which AWS has provided. Right. So do you guys have any questions up to now? Because the next item will be a small demo in EC2. Do you guys have any questions up to now in any of the items which we have discussed? All right, crystal clear. Okay, so in order to create an AWS account, you can go to AWS and go to aws.amazon.com. Here, you have a orange color button called sign into console, right? Sign into the console. You click on it, and typically, unless you are signed in, you will get something like this. Wait. Since I have an account, it's a bit of a problem. So go to this. Yeah, sorry. Usually, if you do not have an account, when you click on sign into the console, it will go to this screen, right? In this particular screen, there's a button called create a new AWS account. So if you click that, you'll get a set of steps which you need to add your personal details plus a credit card. Why they are adding a credit card is most services are free for the first year to use, given that to certain limits, but some of the items might not. So in order for them to be more serious about it, only they'll require credit card. Without a credit card, you actually cannot create any of even AWS, Azure, Google, none of the cloud services you can create without the credit card. So once you have created an account, so I will not show how to create an account. It's quite straightforward. Once you have created an account, it will ask for you to log in. So once you log in, so this is This is a screen where I have logged in to my AWS management console. The AWS console, the GUI which you have in AWS. So if you go here, it will show you some of the recently visited services, plus all the services they provide. This has all the services they provide. So you can either select from here whatever the service you want, or you can simply type whatever the services you want, so that it will show you a list. Have anyone got any experience in EC2? Have anyone used EC2 before? Before that, I think there's one question. Is there any databases in AWS? Yes. So like I said, there's a tool called RDS, which is the managed relational database service which AWS has. So I'll just quickly deviate from the main topic just to show how, what is that. Um, yeah, so this is your database service tool which AWS provides. So you can basically create a database. So you see there was a orange color button called create database. You can create the database. You can select whatever the database servers you want. Some of them might cost you for licenses, for like Microsoft SQL or Oracle, but some of them will be free, like MySQL or MariaDB or Postgre. So you can then simply create a database, because I will not be covering that a lot in this particular session, but it's quite straightforward. Some of the concepts I'll touch upon in the EC2 section, but apart from that, it's quite straightforward. Right, so since none of you guys have any experience in EC2, EC2 is actually the virtual machine service provided by Amazon, AWS. For an example, in good old days, you have a machine that hosts that server for you, right? Similarly, in cloud, we can get virtual machines which are only for us, which we can use to host our servers. So EC2 is the virtual machine service which AWS provides. So how to go to that? We can type in the if you log into management console, you type EC2. So you get the service, you just click on it. So it brings you to the EC2 dashboard. Before going through the EC2 dashboard, I want to show you something. Now I spoke about something called regions, right? In AWS, some or rather 80% of the services they provide are bound to regions. For an example, in management console, you cannot access two region services at the same time. So you can see your region up here in the status bar. You have something called basically it will show whatever the region you are logged into. So in this particular case, for me, it's Singapore. Let's say you want to change that to Hong Kong, right? Now, if you can see, there's one instance for me running here. That's for Singapore. Now, if I change that to Hong Kong, oops, sorry, Hong Kong is quite a different region. So I'll just go to US. Because of Chinese issues, actually, Hong Kong is a completely different region. Yeah. Let's see a region where we don't have anything. Yeah, we'll log into Oregon. So if you log into that region, yeah, seems all my regions have instances. Let's see Canada. right? So in Canada, you can see there are no instances running or instances at all. But if I switch back to Singapore, you can actually see there are two instances and one is running. So we have to keep in mind most of the AWS services that they provide are bound to regions. So you cannot work on multiple regions at the same time in the management console. Right, so we'll quickly run through this because we have to go through the Lambda part as well. So if you go to an instance, EC2, you can click on this instance link. So it will show you whatever the instances that you have, and in some cases that will even show you whatever the instances that you have, but it's stopped, it's not running. Let's say you want to create a new instance. How to do that is, there's a button called launch instances. So what this will do is, this will spin off a new virtual machine with whatever the configurations that you give in Singapore region in your AWS account. So I'll just click on launch instances. So if you click on launch instances, you will be able to see a lot of different images. Now, different OS images, right? We have Windows, we have Linux, we have Mac OS, we have different flavors of Linux and whatnot. So what this will show you is set of predefined images that you can start off with. Amazon, actually, they have their own Linux offering as well, or else if you are familiar with, you can go with something like Ubuntu. So what you can do is, you can just click on select, and when you click on select, you can see there are a lot of different options. These are actually different type of virtual machines. So we have large virtual machines with multiple virtual CPUs, and many number of gigabits of RAM, and some of them will even have RAM like 192 GB of RAM and 96 virtual processors. For example, if you are doing an artificial intelligence server, something like that, you can run something like C5 24x large. But in most cases, for your educational purposes, T2 Micro will be more than enough. And the good news is, T2 Micro is free for the first year of registration in AWS for you to use. So that's why it says it's free tier eligible. So I click on whatever the virtual machine type I want, and I go to the next section. And there are a bunch of different configurations. I will not go through all of them because we have limited time. So we have to go through the serverless ones as well. So this will basically show you what are the different network configurations you want to have, and what are the different CPU options. And even you can give set of script, so to speak, a script that will automatically spin off whenever the server is restarted. For example, let's say you want to spin off your application server whenever your virtual machine is restarted. So you can give that instructions here as well. And next I go to storage. So I can select whatever the number of size of the image I want. You can add more volumes, more hard drives. And I can tag my machines so that it will be easier for me to identify. This most security group with your virtual machines. This is not just for virtual machines, for serverless, for Lambda, for databases, and anything. security group is extremely important. So what this will show you is what are the protocols, what are the port range, and which sources are allowed the access to your server. By default, by default, in most cases, you will only get SSH access, that is the SSH tunneling, because in most cases, before we spin off the application, only the admin, the server administrator should access the server, right? Let's say you want to host a HTML server, basically a web server, which serves port 80. Typically, HTTP serves port 80, right? So I can just select, I can click on add rule. I can select type as HTTP, so everything else will be filled. So I'll just add HTTPS as well. So that what this says is any IP. So what this says is basically any IP can access the port range 80 in my machine. Any IP can access port range 443, which is the HTTPS port in my machine. So then I simply say remove and launch. So I can remove whatever the settings I have put. I can simply click on launch. So when you launch it, it will ask for a couple of things. If you do not have a key pair, the key pair is what you use to log in, to SSH login to your server as the administrator. So if you do not have a key pair, you can create a new key pair. For me, I already have a key pair, so I say I use the Asia key, and I just click on the acknowledgement and I launch the instance. One thing to remember, you should never lose your key pair, because if you lose your key pair, you will not be able to log into your server, or basically you will not be able to SSH into your server. So I just simply click on launch instances. So you can see the instance is actually loading. So I have created an instance before this for demo purposes. So if you go to instances and if you click on the instance ID, you can go to that particular instances dashboard. Now you will have typical stuff like the IP address of that instance, the private IP. This is actually the public IP. This is the private IP address, and what is the DNS and things like that. So let's say now you want to connect through SSH to your virtual machine. So you just simply click on connect. So you have multiple options, but what I suggest is for you to use the SSH client, because that's the typical way in the industry we use that. So now you remember that we have created the key pair, right? So we have downloaded that key pair. So wherever we have the key pair, my key pair is in downloads folder. Increase the size a bit. Can you guys see the screen clearly now? Hello. Yeah, I assume, yeah, perfect. All right, so now my file is actually in Asia key. So that should be somewhere. My key should be somewhere here. I can find it, but anyways. So what I'll do is I'll just copy this command and I paste it and enter. So now I have connected to my EC2 instance. So this is actually my EC2 instance's private IP. So if you go here, you can see this 172.31.40.85. So that's my private IP. So now you are basically in your virtual machine. So you can do whatever you want in your virtual machine. So for demonstration purposes, I have created a server in this particular machine. So I'll just quickly show you the configurations. So now I have created the server. I have created a server prior to this, so I will not cover in this particular one in this session. But now I have created my server, and I have created a small Python routes. One is called the index route, and the other one is called address. So the first one will basically return your name and age. The application server, which is the Nginx, to point to that Flask application. So now, if I run my application, now it's running in port 5000, right? So in my Nginx or my reverse proxy, I have mentioned that I have configured 5000 to be accessed like we are accessing 80 port. So in security, we have given the 80 port the access, right, to any IP. So if I go to my public IP address, if I go to the HTTP, now you can see maybe you can see that it's returning my application, my API. So if I say addresses or address, I think, so it will return whatever things we have. So it will show you that it has accessed the server as well. So it's quite easy. It's pretty easy to spin off your own virtual machine. So that's one way to host your applications in cloud. But there's a major problem with this, right? Why? Let's say your application is only be used in some time. Actually, it used like a couple of hours a day, but scattered. Like someone might use like 10 in the morning and 10 in the noon and 1 in the afternoon and stuff like that. So still, since your instance is running, you have to still pay for that complete 750 hours that your server is running in AWS. So that is not cost effective, right? So that brings us to our second section, which is the serverless. Serverless does not mean that we do not have servers. It's actually there. It's just that the server will spin on only when it's needed. And once the request is been served, the server will shut down. So technically, it looks like there's no server running all the time. So that's what's called serverless. So it's actually dynamically allocating resources rather than having that allocated all the time. And it's basically scalable. You can scale as much as you want, and you pay only for what you use. Pay only for that few hours that you use your application, right? And also, since it's event driven, the service will only trigger, spin off when there's an event coming their way. So what are the events that can trigger servers? HTTP request, a REST API request can trigger a service. Database events. Let's say I'm writing something to my database. I want to do something else. I want to send an email. So database event, write event could be an event. Queuing event, like you have a queue. For an example, you have a message queue. You have an IoT device which sends messages to your queue in AWS. So each message will trigger a server endpoint. Or else there could be monitoring alerts. For example, you have a server. Something is happening with the server. Service needs expansion. So that would be a event. So there are Similarly, you have multiple events that can trigger a serverless application or serverless endpoint. You can think in a very simple term, serverless as functions as a service. Now, when you write applications in academia or even in industry, we have bigger monolithic applications, right? So these applications will have lot of different moving parts. But in serverless, it's mostly functions as a service. So one uh, server or one function will do one thing and one thing only. One function will do one thing and one thing only. So that's why it's called a function as a service. For an example, let's say you have an application which is a booking service, right? Ticket booking service. You have a login. You have a ticket query which sends you a set of ticket data or destinations, and you have a booking service itself, emailing receipts, and the payroll service or payment service. In typical monolithic applications, all of these will be created as a single application and hosted in a server. But in serverless, there will be different functions running in different servers for all of these. You have a login system, authentication system. So you have one function for that, which does only the login. So you have a booking system which only does the booking. You have email function which only does emailing your clients. You have a payment function which does the payment only. So think of serverless as a function as a service, a function as a service. And these functions, very important, these functions are stateless. It means if you are creating an application and let's say you send a request, HTTP request, you cannot keep that request state. You cannot keep that request state in that function like you are having that in a normal server, because just when your function is completed, that will die. So that state will not preserve. So your functions will be stateless functions. So these are a set of providers which gives different serverless tools. So we have IBM OpenWhisk, Lambda, which is AWS offering, Azure Functions, Google Cloud Functions, and Auto Web Task. So major players are these three. With all of these three, the biggest is actually AWS Lambda. So AWS Lambda is a function as a service tool. It's a function as a service tool. So these are the guys who are using AWS Lambda at the moment. Some of them are very popular, like 9gag, Asana, Circle CI, and whatnot. So what are the typical use cases of serverless? So we have EC2 servers, which I showed you earlier, like server virtual machines. And what are the actual use cases? Why should we use serverless? One thing is real-time stream processing. For example, you have a stream of data coming. Let's say you are like pick me, right? You have stream of data coming. You have to process that simultaneously. You have millions of data coming. You cannot scale your application. You cannot scale your EC2 so that it will bill you a lot. It will cost you a lot. So similarly, you can do it very cost effectively in Lambda. ETL is database functions, and you have IoT backends. You have a set of devices which sends data, and you have mobile backends, web applications. So these are set of use cases which can be used with serverless. So that brings us to the pros and cons of AWS Lambda. One, reduce cost of execution, because it costs you only for that milliseconds which your application is running. And it's resilient, because let's say your normal EC2 server can handle only 100 requests per second. Let's say you got million, you have to maybe manually do some work. But in Lambda, it automatically scaled. So you don't have to worry about the magnitude of request that you are getting, and you pay only for what you use. You pay only for that few milliseconds you use. But we should not use Lambda for requests which takes long time. Basically, technically or theoretically, what we say is, if your some application function takes more than 5 minutes, don't even think about Lambda, because it will cost you more than a EC2. And you cannot have stateful functions, like I said, and whatnot. So I'll just quickly brush through because we have to do a demo as well. Have you guys used Flask with Python? Right, okay. So Flask is actually one of the web servers which you can use to write web applications in Python. So Flask is one of the most used. Actually, Netflix uses Flask for their backend, and it's widely used framework, and it's very lightweight. So that's what I'm going to use to show you how to do an application in AWS Lambda. So this is how easy for us to write a server which returns an API endpoint in in Flask. So you only have 1, 2, 3, 4, 5, 6 lines to spin off a server. If you are using Java or anything else, it will take a lot more than this. So these are the guys who use Flask at the moment. So I'm just brushing through this because we are running out of time. Right, so before serverless framework, I'll just show you a small demo how we can create AWS functions, how we can create AWS Lambda functions in AWS Management Console. No programming needed. Maybe a little bit programming needed, but not much. So similarly, I'll just go to my dashboard. So this is my Management Console. So in the search bar, I will type Lambda. So Lambda is AWS serverless offering. So I search for it, and then I click on Lambda. Right. So in Lambda, you would when you come to Lambda dashboard, you will see whatever the functions you already have, and also you will see a button called Create Function. So these are the functions I already have. So if I want to create a new function, I should click on Create Function. Right. So I hope you got it. So then I click on Create Function. So once I click on Create Function, you have set of options that you can create your serverless application or your serverless function. You can author one from the scratch. You can write something yourself, or else you can use a blueprint. Blueprints are actually like predefined servers or functions. For an example, let's say hello world. Yeah, maybe hello world is not there. So hello. Yeah, there's one for hello world. So this will give you all the code predefined. So it will be easier for you. You have many different types of ones. And even you can deploy your own Docker image, or even you can browse a serverless app repository. So don't worry about these. So we'll start one from the scratch, and so if you go to author one from scratch, first you have to give a name. So I say my function, and then you can actually select what is the language, what is the runtime you will be using to create the application, or rather the function. So you have a lot of options. You can have .NET if you fancy Windows application development. You have Go, you have Java, Node.js, Python, and Ruby. So you have other previously supported ones as well. So for this particular one, I'll just go with Python 3.8. and I just simply create on function. So don't worry about these different other configurations. So just simply say create function. So it will take a couple of seconds when you create a function like this, that will not actually create servers or anything at all. Remember, only when you invoke, only when you trigger the function, it will create servers for it. So you have my function here. So once you click on create function, it comes to this particular page, right? So it shows you a designer view of your application and your function code, right? So you have you can have multiple files here, and you can type even here, or even you can actually upload a zip file with your application code. For this particular presentation session, I'll just go with this, right? So what you have is you have the designer and you have the code area, and you have the other configurations, which I will not discuss in this particular one. So in usually, or rather by definition, there should be one function called Lambda handler. In whatever the Lambda function you create, you can have multiple other functions here, some whatnot. But what will be triggered, what will be invoked, what will be executed when you trigger the function will be the Lambda handler. So this is by definition. So there's something called Lambda handler, right? So in Lambda handler, you can so this will simply return a small in this particular function, right? Right. So what once you change anything in this particular section, in this code, you have to click on this deploy button. So what that will do is it will deploy whatever the changes you have done to your function to your Lambda function. Whatever you have done to my car can access that EC2 with the IP address of that particular virtual machine, right? So how to address or how to invoke, how to trigger this function. It's very easy to do in the UI. Remember in the presentation I said there are multiple different events that can trigger Lambda functions, right? Can trigger by database events, HTTP requests, message queues, and whatnot. So to add a trigger, you simply click on this add trigger button, and then you can select a trigger. So you have API gateway as one trigger. So that is HTTP request gateway, HTTP requests, or even you have event-rich events. You have message queues. You might even have database events and whatnot. For this particular session, we will go with API gateway. API gateway is the solution which AWS provides for us to host HTTP or REST APIs. So we just simply click on API gateway. So it will ask what type of API we want to create, right? So REST. Basically, HTTP is also a REST API, but it's a very lightweight one. So we'll just click on HTTP API, right? And don't worry about the security and whatnot. We'll just keep that open. So we don't need any login or anything to access your function. Yeah. If we do not take this, so this particular function will not be able to be invoked from another server. So we'll just tick the course tick as well. It's under additional settings. So we can add that. Now you can see the API gateway has been created. So you can go to your API gateway by simply clicking on that API gateway link in the trigger. So it will open up the API gateway dashboard, right? It will trigger the API gateway dashboard. So here you actually have two links, right? Can you see? There are two links. So these links are the ones which will be which will allow us to access your function, which will allow us to access your function. So if I click on it, copy link, and I open it in a browser, oops. Yeah, sorry, should be. What's this? Yeah. So sorry, I have to add whatever the function API gateway name as well. So if you can see, now it returns whatever you have added in the Lambda function. So if I click on the function again, I go to the code, and I say sessions again, and then I change it. I click on deploy. Changes are deployed. So if I go to my functions, so it will show you that you have changed your function. So that's how easy for you to spin off an API using Lambda functions, right? So I think we are running out of time, so I will not be covering some part of the session, which basically goes with how to automate the Lambda functions. But I hope you got a fair amount of idea how to create an application in serverless and what is serverless and what is AWS. And I think, Hashini, we can open for questions.
Thank you, sir. That was really insightful for those who are interested in this sphere. Now it's time for the Q&A session. You can put in the chat to unmute yourself and ask your questions.
Yeah, so there's one call in the chat. Which type of virtual computer EPU will be utilized in your right? So if I go to EC2, I'll just go to here and show you different types of instance types. So there are few few instance types. For an example, if you're running an AI application like object detection and whatnot, it's better to go for something like compute optimized, because most of the part of your application will be running on compute, because you will not be having a lot of items in your memory, right, in your RAM, but rather your compute should be very fast. So you should be go to something called compute optimized. So there are different ones which you have. And applications or small AI applications, even the free tier 1 is enough. Even the free tier 1 is enough, because it's actually based on how many people will be using that application server simultaneously. If it's only a couple of people, it's always okay to go with a free tier 1 as well. So it goes on to the general purpose. So you can go to T3 micro. How for that, there's something called AWS IoT, which is basically a tool which we can use to get data from mobile devices, or rather IoT devices. Or else there's another tool called Kinesis. Kinesis is actually something like it's an event processor. So you can have your IoT device. Let's say, for example, you have a Bluetooth device, right? So your Bluetooth device will communicate with your mobile app, and the mobile app every 5 seconds will be sending data to your Kinesis streams. So Kinesis is events consumer. So it will get all the events from your mobile application, and it will feed to AWS Lambda. For an example, here as a trigger, you can add Kinesis. So if you add Kinesis, whatever the events that comes to your Kinesis stream, it will trigger an AWS server. So you can read a little bit more on Kinesis and Lambda for that. Yeah, what's the job role for cloud-based software engineer? All right. I'll answer that question after the next one. If I want to ask a simple Flask app, why should I use AWS over Heroku? All right. Heroku, the only problem is it's not that scalable. If you want to do a very simple Flask app, I don't think there's any difference with AWS or Heroku. But Heroku actually do not give you infrastructure as a service. What they give you is basically a platform as a service, right? Yeah, actually, it would be easier for you to run an application in Heroku rather than running that in AWS EC2. But when it comes to industry, so it goes with the previous questions as well, Heroku is used very very minimally in the industry. AWS is being used in the industry throughout. Basically, Wiley, Cisco Labs, and next the places I've worked before, actually all of them use AWS or any other tool. So that brings us to the next question. What is the job role for cloud-based software engineer? Nowadays, every software engineer is a cloud-based software engineer. None of us actually write server code. We actually deploy to AWS or Google Cloud or whatnot. But there is a specific set of engineers as well, which are called DevOps engineers. These guys are specialized not in application logic code, not writing AI, not writing blockchain and whatnot, but they will be specialized in doing deployments, how to manage your cloud, how to automate stuff, how to monitor. So that part goes as DevOps engineer. So that is also a very popular and very highly sought after engineering career for software engineers. But generally, no one can actually run away from cloud at all. So it's basically everywhere. So in years to come, it will be there. So yeah. Any other questions, guys? Sorry, there are other questions. Yeah. I suggest you to get AWS certification. There's one called AWS Associate qualification. But I would say wait for that a bit, because getting that certification without any industry experience wouldn't mean anything. But meantime, go through Udemy courses, go through the courses. Even Amazon itself has their own set of learning tools, which basically gives you tons of information on what is AWS and all. So go through these, and if you are still very keen on getting the certification, there's a certification path which goes as associate solution architect. So that's usually the path you should go if you are interested in AWS. Can we use Lambda for general web services such as? Yes, we can use that to host website, but it's not the ideal use case, because you can simply, if you're only running a website, not a web application, it's better to use other tools. There are other tools like S3, CloudFront, which you do not need compute capacity at all, which you can use for websites, for web servers, web applications. Yes, Lambda is a good solution. Any MSc courses follow regarding it? There are no MSc courses per se for AWS, but there's a certification path, which basically you can go to this tool. This goes under learn. So you can select architect. Maybe to start off with, you can do AWS Cloud Practitioner course, which is a very introductory course. That would be the best thing to start off with. Or else there is a particular learning path where you go with certified solution architect associate, and then you go to professional. So professional is like the highest level in AWS certifications. For simple web-based prediction system, should I use AWS? Okay. Firebase is also a very good option, but it actually drills down to how much of compute power you actually need and how much of control you actually need. Let's say you want to have your databases and even Firestore is there for Firebase. But if you want more control over your servers, if you want more control over your services, then it's better to go with AWS, because you can simply host your database and everything in a EC2. It's very easy. But Firebase, on the other hand, is platform as a service, so it's quite easy to use. Plus, it's considering cost, I would say Firebase wins there if it's a very simple application. Plus, actually, Firebase also runs on Google Cloud Functions. Are there any other questions? All right. So I will share these slides plus the some of the code I have done with, I think, Pvt from Wiley, so that she can maybe share that with you guys. Thank you, everyone.
Okay, thank you, sir. And it seems there are no more questions, and we hope our effort was impactful for all of you. To improve and to know our faults, I invite all the participants to fill the feedback form, which is put in the chat now. Okay, now we are moving to the end of today's session. But before ending, I invite the event coordinator of CSUP Guest Talk series, Ms. Himase Vihanga, to do the vote of thanks on behalf of the society.
Thank you, Pivnika. Good evening to all. It's my privilege to propose the vote of thanks on the CSUP Talks guest lecture series 8th phase on behalf of the Computer Society University of Peradeniya. I take this opportunity to extend our hearty vote of thanks to the guest speaker, Mr. Chathuranga Bandara, who is a senior technical lead in Global Technology Pvt Limited, for the invaluable knowledge session, which was about introduction to AWS with serverless through his very attractive presentation, and Ms. Pvt Paliguru for contacting today's speaker once again. Last but not least, I want to thank Mr. Prabhat Gunatilak and Dr. Daratna for always mentoring us to arrange these sessions, and also to the participants who joined with us today. Thank you.
Thank you, Ms. Vihanga. With that, we finish the whole CSUP Guest Talk series. Hope to see you all from another CSUP session, and thank you for joining.